need to drag this down for our friends who are not here. So today we are in chapter 6, but you will notice when you get your notes that they say chapter 3. This is the discrepancy that came out of Accelerated 7 versus Math 7. And this year I kind of just was going to go with all of the chapter names matching Math 7, so that if you are talking about chapter 6 and a Math 7 peer of yours is talking about chapter 6, it's the same thing. So, unfortunately, when I sent these to the copy center, I forgot to change the header on it. So, whether you want to think we're in chapter 3, that's fine, but I'm going to think we're in chapter 6. So, my advice is at the top of this, just cross out the 3.1 and write 6.1. Because if you go into Schoology and you look for this stuff, it's going to be in chapter 6.1 or section 6.1. So, cross out the 3.1. Being in the front of the row gives you extra responsibility. So we are going to consider this chapter 6. It doesn't really matter what the chapter's called, guys. It's really negligible. It's just that we do things in the right order. So now that we've dealt with division, division leads us to. Mom?
This is another thing. We didn't finish it Friday.
How much did we have left?
We have backwards.
Yeah, we probably don't need to finish them. So sometimes we don't finish all of what we do. So it's the same content.
Okay.
5-5. That was 5-6, right?
We finished the example and then we got it on the bottom. The two problems.
Wow, I need to get some more RAM.
More what?
RAM for my computer. It's how much it can do at once.
Those two problems.
So we had these two left.
Yep.
Let's see if we really need to do it. Show the relationship between days hibernation and change is proportional. Yeah, this is worth talking about. So get back out your 5-6 notes really quick. We'll wrap these up, then we'll run through the 6.1. If you have your binder with you, you should have that with you. So if you don't, that's your fault. So that doesn't mean that they don't get put back in your binder. Your notes and everything should always be kept in order. I suggest chronological by section. So this statement here says in A, show that the relationship between days of hibernation and change in weight is proportional. Now, what does it mean when two things are proportional? That's a really, really important word here. Yeah, sure. What do you mean by even?
They match up. Their weight is the same on both sides.
So let me ask you a question. Do you grow like height proportionally? Do you grow like the same amount every week?
I don't know.
So for a certain amount of your time, you might. Like when you're a kid, you might. But if you look at your life as a whole, do you think I'm still getting taller?
I don't think so.
No, you have these things in your body called growth plates. And as you grow, you start to grow slower and slower and slower. Hey, Dom, you got something to say? Well, if you do, I want to hear it. So, when we talk about proportional relationships, I like to think about food. Because you guys know, I like food. So, a proportional relationship would be like saying, I'm going to give 3 cookies to each student. So, if I have 1 student, I would need 3 cookies. If I have 3 students, how many cookies would I need? 9. If I have 8 students, how many cookies would I need?
24.
Now, this is proportional because 24 compared to 8 is 3 times. 9 compared to 3 is 3 times. 3 compared to 1 is 3 times. They all share the same relationship. Yeah?
Would you also put it in not a fraction, ratio?
Yeah, we could say 24 over 8, 24 cookies for 8 students. We could say all of that stuff. So all that proportional is telling me is that the x and the y have to be related using the same relationship. So can you look at those 2 columns and figure out how they're related to each other. Well, if I'm looking at days of hibernation compared to weight, hey gentlemen, please figure, I don't know why we keep dropping, I guess I thought that was the same thing. Let's stop fighting with gravity. Just leave it on the ground if you can. We want to say, how are these related? Or we could look at the relationship the other way around if we want to. So it says that it is proportional. And it wants the constant of proportionality. The constant of proportionality, I would highlight this if I was you, is what relates our values together. So what we really want to look at for our constant of proportionality, and you can abbreviate that CP, is how much weight changes every day or per day, and per always tells me division. Do you need another copy of these, Julian?
Which one are they?
Somebody help Julian.
5.6.
Oh yeah, I don't know if I have that.
Weren't you
Over there.
Oh, I was. It's just.
So you were here and you can't find your notes. So this is an organizational issue. So when we have an organization check, it concerns me that you currently would not be mastered because you can't find your notes. I think this is the second set of notes I've had to give you that you've lost. This is not good. Maybe I'm mixing you up with somebody, but guys, we're losing notes not even a month into school. You don't even have that much to keep track of yet. Please keep track of your things. Take the extra time now to keep track of them, and you won't waste time later doing them over again.
Oh, I found them.
Oh. So, we want to compare, put them back. I'm not letting you waste that paper. Killing trees.
Tree killer.
We want to look at the constant of proportionality by setting up weight compared to day. So I want everyone to write this on your paper, that we're going to do weight divided by day. So I'm going to do my first one in blue, and then I'll change colors for each of them. So if I do weight divided by day, I have negative 42 hundredths over 7. Now anytime we're working with decimals, you can make your life easier by ignoring the decimal for a minute. Is 42 divisible by 7?
Yes.
Yeah. Andrew, how's it divisible?
It's divisible by 7. So
No, 6.
6. So,
Yes.
So you can make it
0 points.
Ooh, close. Hold on. It's Andrew's problem.
That's what I was gonna say.
So if it was 42 divided by 7, we forgot about 2 decimal places. So if we would have gotten 6, we have to bring back in 2 decimal places. So it's 0, 6. We have those 2 and the negative, because you can't forget about the negative. So we get negative 6 hundredths. Everyone getting this down? Saul, you getting this down, man? So then, ooh, I forgot. I almost forgot. Not cookies, you wish.
I do wish.
As promised, we have cards.
Yay.
So, Noah, what about when I do negative 1.8? So everyone make sure that you're showing the work here. Don't just write down the answers, because then you'll go back and try to look at this and be like, wait, how in the world did we do this? Hey, Jeremiah, you can either figure out how to face forward or you can move your seat. Those are your 2 choices. So, where is Noah? Noah's not, yeah. How would you do this? Can you divide 1.8 by 30? Easy.
No. Not easy.
So, Jeremiah, are you Noah?
Oh, I thought you were talking to me.
No. So Noah, what up here could be divided easily? Ignore decimals or anything you want to right now.
I would add probably another 0 to it to make it 180 and divide it by 30.
Ooh, now that is one way that you could definitely do it. But I don't like extra zeros that we don't need. I love exactly what you said, but take both of those zeros off. Instead of 180 divided by 30, what's 18 divided by 3? 6. So we know we're going to get a 6, but wait a minute. I moved 1 decimal point here and 1 decimal point here. So those two conversions, because one was numerator, one was denominator, make me move 2 decimal points back in, and it gives me the same answer that I had before. So moving a decimal up here to the right will make you, in your answer, move it back to the left. That's why up here we moved it 2 to the right and we moved it back then 2 to the left. So any movements on top, you do the counter to your answer. Any movements on bottom, you do that to your answer. So because we have to do the counter for this one, and we actually do this to my answer because it's in the denominator, so we get negative 6/10 again. And we could go through each of these other ones and we would get the same answer. So my constant of proportionality here is negative 6/10, and that's pounds per day. Because we were doing pounds divided by, or sorry, not pounds. What should that actually be? What per day?
Days of hibernation.
Yeah, but what is the weight measured in?
Ounces.
Ounces. So that's ounces per day. Sorry, be careful with that label. Ounces per day. Yeah.
Wait, you said 6/10. Isn't that
6/100. My apology. Yeah. If I said 6/10, I did not mean to. How much weight does a squirrel lose during 132 days of hibernation? Well, if we know how much a squirrel loses each day, well, each day he loses 6/100. So if that's an each day value, Jeremiah, what would I do here?
We multiply it
By what?
by 132.
Yeah, we just take the per day, or the constant of proportionality, multiply by the 132. That is an instance where I would let you get a calculator. Now we could break this up. I could do 6 times 100, 6 times 30, 6 times 2, and then move the decimals back in. As long as you know how to do that, you don't have to do it every time mentally. You can use a calculator to help you be more efficient. So this comes out to be negative 7.92. How many ounces are in a pound? How many ounces in a pound? 16. So if this is negative 7.92 ounces, that's half a pound. And to a squirrel, half a pound is a pretty big deal. So when you see, like, pretty soon you'll see squirrels starting to get fat because they're going to get ready for winter. They've got to get ready for their hibernation. Dom?
Sort of like an all-time question, but do you know why we put LBS for pounds?
Yeah, it goes back to libras, which is an old system of measurement that was used, I think Greece. I think it goes back to Greece. Don't quote me on that, but it goes back to the word libras, Libras. So LBS. So the table shows the change in one bear's weight over the 84 days of hibernation, and the change in weight is a proportional relationship. So that right there tells me this constant of proportionality, or this relationship, will be the same. So if I figure out how these are related, I can then figure out how these are related. So again, I could just do weight over day, or days compared to weight. But since I'm given days, which division, which constant of proportionality is easier and better to solve, Jeremiah?
You would do 84 divided by negative 7.56.
Now we could, but that would give me days per kilogram. And then when they give me a number of days, I don't want to plug in kilograms. I want to plug in days. Like we did up here, we plugged in days to do this multiplication. That's because I knew my constant of proportionality, and that was weight per day. So since what I have here is days to work with, I want something in per day. So I still here want weight per day. So I'm still here going to actually do my negative 7.56 divided by my 84 actually. Obviously this is not for this problem. I'm just using this space because I cannot scroll any further down. This will give me my constant of proportionality. And that gives me 9/100 of a kilogram per day.
negative 900?
Yes. because it's not very much. If you look at weight change per day, you don't want to be changing much weight per day.
I know a hundredth is only a little bit.
Yeah, but it's over a course of like a
But
month.
900ths is very close to 1/10. So this is very close to a tenth. So then I know that that's the change every day. So after 112 days, we can just multiply my constant of proportionality by my 112, which is the point of our constant of proportionality. It lets me find these unknown values. We're going to do a lot with this when we get to our proportional relationships chapter. This comes out to be they lost 10 and 8/100ths kilograms. Yeah.
So what does WT stand for? Is
Weight.
that weight?
Weight.
Okay.
Yeah, WT is the weight abbreviation. Hey, Saul, write these down. Don't shake your head. Write these down. Switching over to chapter 6, actually, even though it's named 3. Again, I advise you to cross this out and make it 6.1 because on Schoology, this stuff will be housed in the chapter 6 folder. Sorry. I'm not going to run new copies, all because one thing was wrong, so sorry. I don't like running copies. I wish, like, in my ideal world, you would all just have iPads and you would just take notes on iPads.
That'd be awesome.
But we're probably 5 years out from that, if I were to guess. I'd be okay if you guys all had computers, but you'd still have to write. So that's why I like an iPad. You can actually write on it, or a Surface.
You know what would be super cool?
What?
So if they just make desks that were the actual
The technology exists.
This part is actually like
The technology exists.
You know,
They also have 3D sandboxes where you can literally move sand and it's projecting the image down onto it. So as you move sand, you're literally carving into a 3D image. So like Minecraft, just in real life. Yeah. They're making one over at, I want to say Thomas. I know, but they're making one in Worthington. Like we're making a 3D sandbox. Can anybody explain what a repeating decimal is? Before I show the learning target and give it away, can anyone explain what a repeating decimal is? Sean, we haven't heard from you yet today.
Repeating decimal is when you divide something, but it just goes on forever. Like, you can't, almost like pi.
Yes, so, well, except pi is not a repeating decimal.
Yeah.
So, but I agree with the whole like goes on forever. So here's our learning target. I can perform the division between two integers and continue this process until I get a remainder of 0. If a pattern of remainders happens, I might as well bold and underline that, because that's the most important word there. I can identify that this is a repeating decimal value. Because I forget who it was, but one of the, a really nice famous quote is, insanity is doing the same thing over and over again and expecting to get different results. Which is a great quote for middle school because some of you guys try to do the same things over and over again and you never realize this isn't working well. So, why continue to do a division if you get the same numbers over and over and over again? That's insane. Realize it's repeating. I'm done with this process. I have a symbol that I can use. And we use either a ... off the end of it or we use a bar over the top of it. So, we have some really, like, mind-blowingly, but I got interrupted, so I was waiting, mind-blowingly cool relationships in repeating decimals. And the 9s is one of them. Check out this division of 2 divided by 9. How many times does 9 fit in a 2? None. How about 20? Twice. Drop it down, I get a remainder of 2, drop it down, I get a remainder of 2, drop it down, I get a remainder of 2, drop it down, I get a remainder. So I would not continue to drop it down, get a remainder of 2, drop it down, get a remainder of 2, it would be insane to continue to do that because I would just keep getting 2s. Now if I do, let's say 5 9s, write this out over here.
same thing.
How many times does 9 fit into 5? None. Let's do 5, 45. 5, 45. think?
0.55555555.
Okay. So this keeps no.
That's
Your calculator
does that
is stupid. I will swear to you, I will hand on the Bible swear to you. Your calculator is really stupid. It never went to school, and it can't think for itself. Your calculator follows an order of processes called code. If anyone knows anything about code, it's really, really cool. But your calculator can only follow directions. The directions on the calculator is when I run out of screen, do something to compensate for that. What's your calculator do when it runs out of screen? Elena? It rounds. Is rounding accurate? No! Do not round unless told to do so. So, your calculator is wrong here. It's not even close. It's wrong. Rounding, unless you're told to, is wrong. So, do not type these into your calculator and expect to get the right answer. You will not. It will trick you. You will get the wrong answer. Jeremiah?
Why don't they just put the bar?
Because the calculator's dumb.
So they do.
Some calculators can. But the problem is, it is ready to use that number and like take it and do something with it, and the calculator can't understand that something would go on forever. There's a computer program that is running on computers worldwide still dividing pi, because pi is just circumference divided by diameter. So any circle, you can set up a division for pi, and all of these computers all over the world, there's computers at Otterbein that when you put them to sleep, get onto this network, are constantly continuing to divide. All it's doing is performing division, because we have billions of digits of pi. So your calculator can't understand that this 0.5 would actually go on forever. It has to, so that it can make sense of it, end somewhere. So it just puts a 6 there and it says we're done. That's wrong. Real quick, we got to start moving forward.
They will ever figure out how to solve pi.
It's not solve it, it's that we haven't found an end to it because there is no end. Like, we mathematically have essentially, not actually, but we've essentially proven there will never be an end to this number. Their relationship is not a rational number.
Why is pi important?
Because it is the relationship between the circumference of a circle to the diameter of a circle so that you can make a perfect circle. Without pi, there'd be no perfect circles. I'd be happy with that, though, because I can't draw a perfect circle. So, all right, we got to move on. So, what can anybody infer, use what we've seen to make like a hypothesis, can anyone infer a rule for dividing by nines? The rule for converting a fraction with a 9 as the denominator. Ellie?
that the numerator will go on forever.
The numerator repeats. So our rule for converting, and I'm going to write it on the bottom line, but obviously you can start up here. Our rule for converting is, so I'm going to start with the specifics, but when less than 9, because if the numerator was like 10 or 11 or 12, that wouldn't work. But when less than 9, the numerator repeats. And then I would give another example if I was you. So I would, on your line, put like EX 7/9, because we haven't done that one. Would be 0.7777, and it just repeats forever. So don't just put one of them, ... Put a couple, and then put ... Or you can write 0.77, and then you put a bar over the number that repeats. So I can put a bar over one of them, or a bar over two of them, or a bar over three of them. It doesn't really matter, but we don't need it over any of them except for the last digit, since it's only repeating one digit. Sam?
Do you have a preferred way that we write it?
Nope. This is technically, though, called the ellipse. It is your best friend, especially in writing. I love using ellipses. You'll notice on my posts as we do more on Schoology, I use ellipses a lot for just like when a thought isn't totally finished, but there's not time to finish the thought or something like that. So like a lot of times I'll say, oh, we could go really deep into this, but I digress, ... Like I'm going to move on, but there's a lot more that we could talk about here. So now converting by 11s, and this did not capture yet, so I'm hoping that it will. Hello. So 11 is weird, but it relates to what we just talked about. I want you to try to figure this out by a little bit of checking. Maybe it clear. I think it cleared instead of capturing. So we see 2 11ths. One of my favorite bands is a band called 311. Let's try 3 11ths. 11 fits into 3, none into 30, 2 times. Gives me 22. Drop down an 8. Guys, we should be writing this long division if for no other reason than the fact that we haven't done it in a long time. How many 11s fit into 80? Well, that would be 7. How many 11s fit into 30? Well, I can do 2 again. Now I get 8. Oh, okay.
This is gonna go on forever.
Once I've gotten the same pattern twice, I know that it is going to continue giving me the same pattern.
Is that for every division problem?
Yeah, I mean, once a pattern starts, you can't break out of it. Because this remainder of 8 gave us the remainder of 3, which is then going to give us a remainder of 8, which is going to give us a remainder of... So, we see this pattern starting. 3, 8, 3, 8.
Is there any division problems the pattern changes?
We'll always say.
I mean, like pi.
Why is it called
So, if 2 11ths repeats 18, 3 11ths repeats 27. I'll give you another one just for an example. I'm coming to you. I'll give you another one. Why are you... Okay, I thought it was just clearing instead of capturing. I'll give you another one that I'm not going to show the division. But 4 11ths... that looks too far. Repeats 36. Sam, did you figure it out?
Yeah, the numerator is multiplied by 9, and that's the pattern.
The numerator multiplies by 9, and that's what repeats.
She's right.
So 5 11ths, what would 5 11ths be? What would repeat? 45, right? Whitney already said. But if it repeats multiple digits, if you're going to use the bar, it's got to be over both digits that repeats. What about 6 11ths? Okay.
Okay. 54.
54. We don't have to do any division. This rule will always happen. What about 10 11ths?
90.
It repeats 90. So if you're doing 10 11ths, you have to be careful because you might think, oh, this 0 doesn't really matter. Well, yes, it does as soon as I put another 90 there. So we have to repeat the whole, both digits, the entire 90. So I would write that on your paper if I was you. Hey, Julian, do you need to move? Or are we good? Okay. Make the mature decision. I'd rather not force you to move. That's embarrassing. So if you need to move, move yourself. So I would, if I was you, write numerator times 9. And actually, you could put in parentheses, numerator times 9 repeats. What? Say that again, because I'm worried that what you said is not actually true. Dividing by 11. This is now division by 11. So division by, and this is what's weird. Division by 11 multiplies by 9. Division by 9 just repeats whatever's on top.
Oh, that'd be nice.
Which actually Could we make this rule any easier? Think about it like this. Division by 11 multiplies by 9. Could I say, well, crap, I forgot to capture that, but whatever. Could I say division by 9 multiplies by 11?
Yes.
Yeah. Because the numerator times 11 would just give you that number repeated. So division by 9 multiplies by 11. Division by 11 multiplies by 9. That rule works back and forth. All right, ready to move on? Yeah.
This is just a fact about the repeating.
This is just a fact.
Yeah. So
I like how you intro that.
all numbers have rules of divisibility. Like six's rule for divisibility is
Yeah.
the number has to be divisible by 2 and 3.
Yep. At the same time, because the 6 is 2 and 3. Huh? Yes. Yeah. All types of repeatings. The 7s are honestly where my mind, like, still it blows my mind. But we'll get there in a second.
7?
So 7ths.
7 does
Just
not.
wait. Yeah, it does. So repeating, multiple ways to represent. They only show you the bar here. Here, these are not repeating. No bar or ellipse. There's also the ellipse, so you might notate that if we want to use the ellipse, especially in a situation like this, you want to write the pattern twice. And then you cannot just do this. This is not okay because we don't know what repeats. We would either need to write the 4 if that's what repeats, or if the 5 and the 4 repeats. I actually like to show it 3 times and then show the ... So my real suggestion is just use the bar. If it's more than one number repeating, just use the bar. It's easier that way. So down here, is number 1 a repeating decimal? Hold up. Now we'll use cards. This is what's great about cards. So Jaslyn, is number 1 repeating? Yes. What does it repeat? 85. Sean, does number 2 repeat? No, because we have 4, 0, 4, 0, 0. 4, there's no pattern has started, so we can't really see anything. What about number 3, Anish? It does repeat. What does it repeat? Since it doesn't show us a pattern, all that we know is that repeats the 2. So this would be 1.72222. The ... we can only assume 1 digit because we haven't seen a pattern. Now, if it had done 727272, then that might be different. Like if it did 727272 ... then we could assume it's repeating that pattern. On the back, we should be able to fill in all of these. So go ahead. With our rules from the front, we should be able to fill in all of these. Actually, I'm going to skip past that because we are pressed for time. So 7/15. Just go ahead and skip on down here. Don't worry about filling in that table. 7/15. Remember, numerator goes inside, denominator goes outside. A bunch of zeros. So how many 15s fit in a 7? None. Go ahead and start your 0 with the decimal. Then, Ashley, can you help me out a little bit? How many 15s fit into 70? So you can count up by 15s. Yeah, 4 of them, which gives me 60. I get a remainder of 10, so I can drop the 0 and make that 100. Monica, how many 15s in 100? 6, and that gives me 90. So I get a 10, I can drop down the 0 and make 100. And at that point, we see that I have now repeated my remainder. Hey, Julian, why don't you go ahead and move over behind Anish? And I'm going to need to see you after class, please. So since this remainder repeats, we know that the number that comes out of it will repeat. And this 6 will keep going on forever. So that only repeats the 6, even though it started with a 4. So how the decimal starts does not really tell us anything about what it's going to do. Now the 7ths. You ready to get your mind blown?
Yes.
I might need some more paper towels to make sure we can clean this up. I challenge you to see the pattern.
Oh my gosh.
Take a minute. I challenge you to see this pattern.
What?
Shh. If you see it, don't say it. If you see it, don't say it. Let other people find it. Let them have that moment of discovery. Quit talking and think. Now, Sean, you said you see it? Without telling me what it is, without using a calculator, what do you think 3/7 is going to be?
I know the method. I just add it up.
3/7 gets weird. That's why, like, even if you see it. All right, can you figure out 6/7?
It will be.
Jeremiah, do you know 3/7? Or either of them, really. I'll give you a hint on each of these. We're not done. Do not write these down and think that we're done.
Oh, it's 8.
Okay, I'm almost done.
Why is it? I'm so confused. I don't see it anymore. Oh, you.
What? Did you do all of that math in your head?
Nope, I did none of that math in my head.
He used calculator.
I did not use a calculator.
He just remembers it. See, I got.
What are the multiples of 7? What are the multiples of 7?
Oh my gosh.
Life hack Larry.
Is 14 a multiple of 7?
Yeah.
Is 28 a multiple of 7?
Yeah.
Is 57? No, but it's close. 14, 28, 57. 28, 57, 14. 57, 14, 28. 7, okay, so the 7 is chopped off the 5. So 14, 28, 57. 14, 28, 57. 14, 28, 57. It's the same cycle of numbers, just shifted through. This is all of them, because the next one is 7/7, and then it would be 1. So here's why I left 3/7 and 6/7 blank. Those get weird when the numbers get chopped in half, but it's the same cycle of 142857, 142857, 142857, 142857, 142857, 142857. Like, it's the same cycle of numbers. Should be mind blowing.
How does the cycle work?
If you do the long division, that comes out. We can prove it. We can take the time to look at all this, or you can just I'm not really asking you to memorize these, but you should be able to pretty quickly say 1/7 is 14, 28, 57, and know that that's all repeated. Then it just works its way up. 1, 2, the next biggest number is 4, the next biggest number is 5, the next biggest is 7, and the next biggest is 8, and it keeps the cycle going in the same order. Yeah.
Calculator wrong again. I did 3 divided by.
It's wrong again. Your calculator's wrong again. Do not trust your calculator when dealing with repeated decimals.
Can you buy a better calculator that actually gets it right?
Depending on the settings that you turn your TI-80, so if you have a TI-83 or an 84, you can go through the settings and tell it to do or not to do what your calculator is automatically doing. Yeah. So I don't think you can change the settings on the lower one. Sometimes you can, where you set the decimal to float. If you're able to set the decimal to float, it'll try to take it out as far as it can, like as many decimal places. We shouldn't really need to do these. We might wrap these up really quick at the beginning of tomorrow, but all that we would do is convert 7/12 to a decimal and compare. Same thing here, we would convert 5/12 to a decimal and compare. So when you see problems like this on your homework, it's just convert and compare which one is bigger. Try to do these without a calculator. I encourage you to do these without a calculator because you're going to be asked to do this without a calculator on your mastery. There's your warning. Have a great day. Your mastery for chapter 5 is on Thursday.
So we're doing the got it for homework calculator?
No, you never have to finish your notes as homework. We just sometimes don't make it all the way through your notes. The worst case scenario would be we finish your notes and I have nothing else to do. So I a lot of times put things on there we don't have to do, but it's an if we get to it sort of thing.